Welcome to the Engineering with Nature podcast. The U.S. Army Corps of Engineers has been working on the Engineering with Nature initiative since 2010, working and collaborating to advance the use of natural processes and systems to deliver a broad range of economic, environmental, and social benefits. EWN develops and implements nature-based solutions for water and infrastructure projects. It brings together a growing international community of practitioners, scientists, engineers, and researchers to harness the power of nature to innovate and solve problems and create sustainable solutions. This podcast tells their stories. Now here's your host, Sarah Thorne of Decision Partners.
Coastal ecosystems provide an essential part of the solution to global climate change, along with multiple benefits. Among other things, coastal ecosystems sequester and store blue carbon from the atmosphere and from the oceans. So what is blue carbon? Well, it's basically the good carbon that's stored in coastal and marine ecosystems. And today, we're talking with leading scientists about their work and understanding how that blue carbon is helping to address climate change. Welcome to Season 5, Episode 9. Jeff King, National Lead of the Engineering with Nature program with the U.S. Army Corps of Engineers, and I are very pleased to welcome three guests to our podcast. Lisa Chambers is Associate Professor of Biological Sciences at the University of Central Florida. Welcome, Lisa.
Hi, thanks for having me.
Jenny Davis is a research ecologist with the National Centers for Coastal Ocean Science. She works in the Beaufort Lab, Marine Spatial Ecology Division of NOAA, which is the National Oceanic and Atmospheric Administration. Welcome, Jenny.
Hey, thanks. Thanks for inviting me.
And our third guest is Jeff's Army Corps colleague, Jacob Berkowitz. Jacob works in the Engineer Research Development Center and is a research soil scientist and lead of the wetland team. Welcome, Jacob.
Thank you, Sarah and Jeff, for the opportunity.
So, Jeff, in Season 5, Episode 8, we talked with Daniel Hayden, who's the CEO of Restore America's Estuaries, about the critical importance of bays and estuaries. Why was it so important to follow that episode with these scientists talking about coastal ecosystems and blue carbon?
We did have Daniel on, and he offered what I would call this high-level insight into the importance of estuaries. And so with this episode, we're going to get into the weeds a little bit, or maybe I should say into the salt marsh grasses a little bit more. And so we've assembled what I think are wonderful guests to be able to walk us through this topic of blue carbon, what is happening with respect to science, engineering, the importance of understanding these processes. And so that's going to be the topic that we'll focus on today, and really excited to get into that and hear from our guest.
Well, excellent. We are really thrilled to have the three of you with us. I'd like to start by asking Lisa, you're the professor, we'll talk to you first, to talk about what blue carbon is and help us understand why it's important.
Blue carbon is a term that's been around for a couple of decades now. And it's really referring to these vegetated coastal ecosystems, typically things like marshes, mangroves, and seagrasses. And the reason that we gave it a special term, blue carbon, is to really differentiate it from some of the other ecosystems we think about that sequester a lot of carbon. Many people focus on terrestrial forests, but it turns out that these coastal ecosystems can actually sequester significantly more carbon than most terrestrial forests. And importantly, in addition to sequestering that carbon, they store it for long periods of time below the ground in the soils. Oftentimes 50 to 99% of the carbon that they sequester gets stored below ground. They also have a lot of other co-benefits like habitat and shoreline protection.
So thanks for that, Lisa. Jacob, I understand that you're working with Lisa on a really significant project. Can you tell us a little bit about your work together?
Yeah, thank you, Sarah. In general, there's increasing interest across the Department of Defense and really across the full federal family of agencies in understanding carbon dynamics and identifying opportunities to increase the sequestration of carbon. And so we were asked by the leadership within the Engineering with Nature program to investigate blue carbon within the context of our ecosystem restoration, our navigation programs, including how we use dredge material beneficially to restore and create coastal habitat. And so that's provided us with an opportunity to really look at blue carbon within an applied research context and to see where the opportunities exist to really maximize how we can encourage the storage of carbon within these coastal systems.
Great. And Lisa, talk a little bit about why this project is so different.
Yeah, I was really excited about the opportunity to collaborate with Jacob and his team because there are so many possibilities for restoring coastal wetlands and blue carbon ecosystems with dredge material. We know that it takes a long time for carbon to naturally accumulate in wetlands. But one thing we've learned is that really not all carbon is created equal. So there's different types and different stabilities of carbon that accumulate in blue carbon systems. And particularly, we found that some of the most persistent and long-lasting forms of carbon are often in association with fine silts and clays. And it turns out that dredge material often provides these fine silts and clays. So this provided us an opportunity to look at it from a research standpoint and see if this engineering with nature could actually improve not just carbon storage in blue carbon ecosystems, but also the stability of that carbon.
Obviously, this has a lot of importance from the standpoint of the EWN program for many reasons. Certainly, when we think about engineering with nature and the idea of engineering benefit, but also creating environmental and social benefit, this is one of those areas where we see tremendous potential for environmental benefits. And the other sort of aspect of this, as Lisa mentioned, is with the idea that we are dredging, the Corps of Engineers, on average, about 200 million cubic yards of dredge sediment every year. And so the idea that we could really use this dredged sediment for purposes of outcompeting sea level rise and being able to replenish salt marsh systems and thereby actually increasing the potential to sequester carbon is a very, very good thing. So just really excited about this work that they're doing within the program.
It's really cool, and it really takes beneficial use of sediment to a whole new level. We've been talking about in previous podcasts about sediment really being the next currency in terms of for climate change. So that's really exciting. Jenny, I understand you're doing really cool work as well. You're looking at carbon that's stored in dredge material, but you're doing it from a slightly different perspective. Can you talk about that?
Yeah, so on a very related topic, but a little bit tangential, we're taking a very site-specific approach to understanding what happens when you restore a system with dredge material. So, we can go in and have an understanding of the carbon budget of a marsh that, in its natural state, but then when you add dredge material to preserve that marsh, to build it up in the tidal frame so that it has some resilience against sea level rise. Now, how have you changed that budget overall? And that's the kind of question that we're looking at. It's very, very much tied into the kind of work that Lisa and Jacob are doing, and they're super complementary. So it's really exciting to be here and talk about these topics together.
Yeah, and what I would say here is that whenever we can get the Army Corps of Engineers and NOAA together collaborating and talking about these kinds of topics, it really does accelerate our understanding of these kinds of systems and processes. And so I'm just really delighted that we do have these kinds of opportunities to bring folks like Jenny, Jacob, and Lisa together to really have that kind of communication, to be able to move data sets around, very complex data sets around, and to be able to really gain a more comprehensive understanding of all these different types of systems by being able to work collaboratively in this space.
So important, and really moving the needle on how you're even thinking about the benefits and the value of blue carbon. I want to talk a little bit now about how these blue carbon ecosystems are threatened. And I'm thinking, Lisa, maybe you could lead off and talk a little bit about the importance of mangroves and also some of the risks that they're facing.
All of these coastal ecosystems are changing as a result of various changes in our Earth's ecosystems and climate. We're seeing shifts. We're seeing sea level rise because they're really on the front line of that continental margin. Sea level rise is a big threat to blue carbon ecosystems. In Florida in particular, we're seeing a major expansion of mangrove coverage. So mangroves typically are more of a tropical species, but as freeze events become more and more rare, those mangroves are moving further and further poleward. And mangroves are very important to sustainability of coastal ecosystems. They serve as a major barrier for communities that exist behind them. They help prevent erosion, and they're extremely important as a habitat for both commercial and recreational fisheries.
Yeah, and Lisa, I was wondering if maybe you could take this a step further for us. I know you are knowledgeable and looking at things happening now underway in Florida to protect mangroves, and maybe you could talk a little bit about that for us and share your thoughts with our listeners. Just for purposes of thinking back to some of our other podcasts, we did have Tori Tomachek with the U.S. Naval Academy on. This was back in season 1. I believe it was episode 4. She offered some perspectives and insights on mangroves and her research. And so certainly now getting a chance to talk with you about what's happening in Florida, I think that would be a wonderful topic for us to explore here with our listeners today.
Yeah, it's being increasingly recognized that mangroves serve a lot of ecosystem services. So in addition to things like protecting shorelines, we recognize the importance of mangroves as habitats and as blue carbon reservoirs. Here in Florida, in the 1990s, they passed a legislation that actually protects mangroves from trimming, removal, and any sort of destruction in recognition of the important role that they serve on our coastal ecosystems. They also are major carbon stores. So there's significant research going on right now looking at how mangroves might help to enhance carbon sequestration into the soil as they move in and encroach further poleward.
Really interesting work, Lisa. Thank you. I'd like Jacob to talk a little bit about soils because they're also being, they're threatened by climate change, and particularly talk about soils in tidal marshes and why protecting them as blue carbon sources is so important.
If you look historically, just in the United States, more than half of the wetlands have been converted to other uses or otherwise degraded. And while we've made strides through legislation and regulation to decrease the rate of wetland loss in the United States internationally, some of those rates continue to increase. When we lose these coastal wetland areas and we lose the soils there, or they're converted to other uses, we also lose the blue carbon that's stored there. So we lose the ability to take carbon out of the atmosphere and store it in these long-term protected forms beneath the ground, where they're protected not only from the release of the environment, but also from threats like wildfire that we anticipate to increase over time. And so in many of these coastal systems, we have very deep, oftentimes several meters or multiple yards of material that is very high organic carbon content. And so it's just a massive store of carbon. These tidal ecosystems represent a relatively small portion of the Earth's surface, but they store more carbon, much more than twice all the forests on the planet. So it really is just a massive store of carbon and a really incredible resource. And these systems have shown extremely high levels of resiliency to things like coastal storm surge. So when we protect these systems and allow them to function, not only do we get these carbon storage benefits, but we also see benefits to the to the homes and communities that are behind these systems, as well as opportunities for recreation, support for fisheries and other habitats. So when we really protect the soils, we're doing a lot to protect ourselves and protect society that lives along the coastline.
That's really helpful. Thank you. And I just, as I was listening to you talk, I was thinking we need to just do a real quick explanation of why this carbon storage is important. Can you just crystallize that for us, Jacob?
Yeah, well, these coastal ecosystems really play a key role in helping to regulate the global climate because there's a balance between carbon stored in the soil, in the atmosphere, and in the oceans. When that system becomes out of balance, that's when we induce the type of climate changes that we're increasingly beginning to see. And recent research has demonstrated definitively that because of increased carbon content in the atmosphere, we're seeing more destructive storms, and the likelihood that we're going to see things like multiple storms hitting our coastlines in the same year are really starting to increase. And so the blue carbon storage that we talked about and trying to promote blue carbon as a mechanism to take carbon out of the atmosphere and store it for long periods in the soil is one mechanism, one tool that we have to help us to essentially rebalance the carbon system. That being said, it's going to take a lot of work and a long time to try and get to a more balanced carbon budget globally. But these coastal wetland systems will play a key role in helping us to achieve that goal.
Oh, that's really helpful. Thank you. So we're trying to use this blue carbon, it's in your words, to help rebalance. And we're dealing with the threats, climate change threats from sea level rise, but also destruction of these ecosystems. I understand that. So let's come back and talk a little bit about the value that these ecosystems provide and how the work that you're doing is really contributing to protecting these critically important ecosystems. Jenny, can we start with you?
Sure. So Lisa and Jacob just kind of laid out a lot of the values that we get out of those systems in terms of storm surge protection and habitat and all of these other reasons that we really value those systems. In addition to blue carbon, we know that they're threatened by sea level rise and human modifications of those, and so restoring those is really critical to starting to restore that balance that Jacob talked about. When we start to really quantify the value of any reason to restore them, and for example, in terms of blue carbon, how much blue carbon do you actually get out of a square meter of restored marsh? It helps to incentivize that restoration. And so really, keying in on how can we maximize the benefits of these restoration actions is a win-win for all of those benefits that we look to marshes and mangroves for.
And Lisa, you've done some interesting work on that, right? On quantifying that value.
Yeah, we look a lot at quantifying carbon and, again, looking not just at the total amount of carbon, but also the stability of that carbon in these ecosystems. The other thing that we're studying a lot is trying to understand when these coastal wetlands do get destroyed, what is the fate of that carbon after the destruction? And so we've done some research, especially in Louisiana, where they're seeing really high rates of coastal wetland loss as a result of submergence due to subsidence and sea level rises. What is the fate of that missing carbon? Does it cycle back into the atmosphere where it can contribute to climate change? And a lot of our work shows that, unfortunately, it seems to. When they see high rates of submergence and edge erosion, a lot of that carbon gets mineralized by microbes and released back into the atmosphere as CO2. So one of the key things that we need to make sure we do is to keep that carbon sequestered in the soil in its most stable form so that it's not contributing to additional climate change.
And I think that's really important. One of the things that, I learned when we did our pre-call was that the work you're doing, you and Jenny and Jacob are doing, really shows that the older, longer the carbon has been sequestered, the more benefit it has. Am I saying that right, Jenny?
Well, yes, in the sense that, as Lisa mentioned earlier, there's part of that carbon that turns over very quickly. So if you think of a leaf falling off a tree, it falls on the soil, and a lot of that material gets decomposed and goes back into the atmosphere right away. But that, the part that's more resistant to being broken down is what gets stored. And so the older you get, in that whole marsh soil, the more resistant that material tends to be to being converted back to CO2. And so those old stores are really, really important.
And that's what you're doing with your core sampling. You're trying to look at some very old samples, right?
It's always very interesting, to look at the age. So when we take cores down those deep, deep marsh sediments, and you get down, in some cases, a couple of meters, and we can use radiocarbon isotopes to date when that material was deposited. In some cases, it's 2,000, 3,000 years ago, which is just a really cool realization when you're standing there looking at that material. But also, I think it's really important to think about how long it took to build all of that store of rich carbon. And so when you lose it, it gives you an estimate of how long it's going to take to replace it by that same mechanism. It's really important to preserve those stores.
Yeah, Jenny, that's great insight, and certainly offers our listeners some real context in terms of how long that has been around in some of these systems that we're talking about today. And certainly I think about, going back to some of the original conversation here about the tools that we have to sustain these various systems and the need to really beneficially use dredge sediment. I mean, think about what we have within the core now and Chief General Spellman's goal of 70% beneficial use by the year 2030. And I think that the work that you're doing has real ramifications and certainly justifies the need to see more beneficial use happening. And just for our listeners, one of the sites that Jenny's working on is Swan Island in the Chesapeake Bay. And as our listeners may remember, we had an episode on Swan Island. Paula Whitfield from NOAA offered some insight on what was happening at that particular restoration site within the Chesapeake. And so now it's great to know that Jenny is out there doing some additional sampling and helping us to better understand more about the importance of these island systems and why we need to be restoring them when we can.
Absolutely. And I want to also talk about the work that Jacob is doing on really the value of preserving these blue carbon ecosystems. I know that Jacob's worked on a number of projects that we have talked about on the podcast. Maybe you could talk about what you're working on now, Jacob, and what's ahead for you.
What's really exciting about the work that we're doing now is that over the last several decades, the research has really borne out opportunities to target different ecological functions. So, for example, we've gotten pretty good at knowing how to design projects to provide habitat for a specific species or a variety of species. And we also know how to build projects to maximize ecosystem benefits like improving water quality through denitrification and the removal of excess nutrients. And so as we think about where we are within this blue carbon research, I think that's what we're really going to be striving towards in the coming years. Is how do we take the really important foundational science that people like Jenny and people like Lisa are doing, and how do we translate that into actionable guidance for our engineers and our practitioners so that they can build projects that are going to really maximize the carbon uptake within the plant, but also provide opportunities and foster the opportunity to sequester as much of that material in the soil over long periods. And so we're starting to kind of nibble around the edges of that in terms of where to build projects, what target elevations to look at for projects, and what types of coastal habitats are going to be the most successful in regards to blue carbon. And so that's what we're really looking forward to in the next couple of years, is kind of taking this foundational science and bringing it to the practitioners in a format that they can understand and use at increasingly larger scale.
Yes, and we need that kind of guidance sooner rather than later. And we've got wonderful people like Jacob and his team, Jenny and her team, and Lisa and her students that are all contributing greatly to our understanding and the ultimate goal of getting to this guidance for practitioners. And certainly, I look out across the landscape when thinking about organizational sectors, and everybody's thinking about this. And we're starting now to see entities like Department of Navy or Army including blue carbon or carbon sequestration in their climate action strategies and their plans. And that is really, really, I think, a pivotal kind of shift in terms of how Department of Defense is thinking about opportunity here and how they're going to manage installations and all of that land that they're responsible for. So it's wonderful to see that. And again, sort of connecting the dots here, it is the scientists and engineers that are moving the needle and helping to contribute to what we ultimately will be doing in the landscape.
Wow, I'm listening to you guys talk and I'm hearing so many great opportunities for students in the future. I wish I could go back to school and start all over again because I can just imagine what I'd like to be. So, Jeff, one of the goals of our podcast is to inspire the next generation of brilliant scientists like these folks that are doing this really critical foundational research.
That's right, Sarah. And so what is interesting, I think, on many levels, certainly for my job, is I have the chance to work with students and get to talk with students all the time. And that's a highlight of what I get to do each and every day. And so I have no doubt that the topic we are covering today and the work that Lisa, Jenny, and Jacob are doing is going to excite a lot of students. And so I wanted to make sure that as part of this podcast, we had a chance for our guests to talk more about what it's like a day in the life of their research and being out in the field or being out in the lab. And what is it that you really appreciate? And maybe one or two stories of something that perhaps students would find interesting.
Let's start out with you, Lisa. Tell us about a day in the life of Lisa Chambers.
Just like Jeff, the best part of my job is really inspiring young students to get involved in research. And as a university professor, it's really wonderful to be able to expose my students to research that's going to result in some real tangible data that can be applied and can actually change the direction of various projects that are really happening on the ground. That's such a fantastic benefit for them and great experience. We have a lot of fun. We work really hard, but it's really something special to be able to go out into some of these coastal wetland systems. Not many people walk in them. Most people kind of look at them from a distance, but we get our knee boots on, sometimes our chest waders, depending on the system, and we trudge through the mud. And it is treacherous. One step you're standing on top, and the next step, all of a sudden, you're waist deep. So it can be quite an adventure collecting our soils. We take all kinds of equipment that will pound into the ground and try and collect intact soil cores just as deep as we can get. The field work is definitely what the students remember the most, but it seems like for every day in the field, there's at least 2 months in the lab afterward. So we collect those soil samples from the wetlands, we bring them back to campus, and we start to analyze them. And some of the work that we're doing that I was referring to earlier, such as looking at associations between carbon and minerals, that analysis that we've developed, it takes about 12 days to analyze a single sample from start to finish to figure out how much carbon is associated with minerals in those soils. So it's a pretty intensive lab process, but it's really rewarding to see the results.
It sounds fantastic. Absolutely fantastic. Jacob, how about you? What's your perspective on field work and analysis?
Well, yeah, I couldn't agree more with Lisa. There's really this wonderful give and take between where I am in my career and working with students and really a lot of working with those junior scientists. I think we're all very passionate about what we do, But you better believe that these young people, they match, if not exceed that passion when you start to talk to them about these concepts. And so what I like about our job is that we have a very good distribution of, we get to go to the field. We also get to work in the lab, and then we get to do a lot of writing and teaching and these kind of public outreach things like we're doing today. And so it's really balanced where we're not just doing the same thing every day. And I find that especially the young people, they really want that kind of diversity in their work. They don't want to be doing the same thing over and over again. And so working in this field really allows you to kind of choose your own adventure, if you will, in terms of what you want to pursue in a given day or a given week. And in terms of kind of some examples, I mean, just for this Blue Carbon project, we'll have staff traveling to Florida and Chesapeake Bay and Mobile, Alabama, as well as study sites in the Great Lakes and out in California near San Francisco. And so when you have the opportunity to travel and see these different coastal ecosystems across the nation, it really enhances your view of how coastal systems work and the similarities and differences between different systems. And so one of the things that I like to think about when I talk to students or junior staff members, again, there's a lot of the foundational sciences going on now, but I really like to challenge the young people in the next generation that, it's going to fall on their shoulders to really scale these types of efforts up to the global levels that we need to have a regional impact.
I think that's really sound advice. And I'm sure one of the things that you all find when you're traveling to different sites is just the knowledge of how critical this work is and how short the time is to do this really important foundational work. And then to Jacob's point, really, really scale it up so that it, can benefit, it can benefit society, can benefit the ecosystems. Jenny, I want to talk to you. What does a day in the life of a NOAA researcher look like?
Well, I guess I would echo Lisa and Jacob a little bit in saying that no 2 days are the same. And that's one of the great things about it. I think we end up in all these different locations. We end up in, doing a slightly different task every day. It could be lab work. It could be field work. If you're in the field, it could be incredibly remote, or it could be in an urban estuary where people are coming up and talking to you and asking you what you're doing and getting excited about it. And you might be seeing bears or alligators in your marsh, depending on where you're at. But I think that variability makes it pretty easy to attract students and interns and things. It is incredibly challenging, but a lot of fun as well, and satisfying to know that we're doing something that hopefully contributes to some pretty big problems that we're facing as a society.
Oh, yes. Yes, you're all contributing greatly to our understanding and advancing how we will ultimately develop future projects and how we will restore areas in the coastal environment going forward. And I just want to take this minute to say thank you to all of you for what you have shared with us today. I have no doubt that our listeners are going to really appreciate this insight. And so I want to certainly think about how we might get you back on the show at a later time as more of these results are made available. And let's talk more about this interesting topic. So thanks again for joining us today.
Absolutely. There's so much more that we want to hear about. Thank you, Lisa, Jenny, and Jacob. Really, you've given us thoughtful and important insight into the critical role that blue carbon plays in offsetting the impacts of climate change in coastal environments. And certainly from what you've said, I think you'll absolutely inspire students who are interested in pursuing research careers like yours. As you've all said, there's really important work to do building on the foundation that you've started. So lots of opportunities for students ahead. It's really, really important work. And we thank you for sharing it with us on the Engineering with Nature podcast.
Thank you.
Thank you, Sarah and Jeff, for the opportunity.
Thank you for the opportunity.
We will check back with you all in the future to see how you're doing with your work. And to all of you, thank you so much for listening. We hope that you've enjoyed this podcast, and we hope you'll join us again when we talk about engineering with nature.
You've been listening to the EWN podcast, developed by Sarah Thorne and Jeff King, National Lead, Engineering with Nature Initiative, U.S. Army Corps of Engineers. Now, for more information, you can visit our website, engineeringwithnature.org. The EWN podcast is produced by iContact Productions for the Engineering with Nature program within the U.S. Army Corps of Engineers. I'm Dave Trafford.